Welcome, everyone. I'm Steve Curwood, executive producer, host, and founder of Living on Earth, and we are here today for a Living on Earth book club event, co-sponsored by our media partner, Inside Climate News, and the UMass Boston School for the Environment. Living on Earth is a public radio program and podcast that's been bringing you inspiring stories and conversation on climate change and the environment every week for the past 35 years. And now, our partner, Vernon Loeb.
Hello, everybody, and welcome. I'm Vernon Loeb, executive editor at Inside Climate News. We are proud to call Living on Earth our partner and collaborating newsroom, and we're really so pleased to be co-hosting this Living on Earth book club conversation tonight alongside with UMass Boston School for the Environment. Our guest tonight is Dr. Hannah Ritchie, a Scottish climate scientist and data maven who has really made quite a big name for herself as a climate realist and optimist by using data and science to cut through all the greenwashing and spin and obfuscation, misinformation, to argue that it is not too late to save our planet from runaway climate change. Hannah has a PhD from the University of Edinburgh, and she's a senior researcher at Oxford's Martin School. And she's also the deputy editor of Our World in Data, the remarkable open access platform that translates the hardest global data for policymakers, journalists, and ordinary citizens. Hannah's new book is called Clearing the Air, and she takes on climate change in 50 questions and answers. Because, as she's written, people motivated to act often end up feeling paralyzed by conflicting information, and she wants to give them clear and honest answers about whether we stand a chance. And her answer is we absolutely do, with solutions that are already in hand. Every tenth of a degree matters, she writes. There's no point at which it's too late to limit warming and reduce damage from climate change. She goes on, the good news is that we're no longer heading for the worst case scenarios that scared me as a teenager. The bad news is that a 2.5 degree warmer world, which we're on course for, is still a scary and unacceptable one. So please welcome Dr. Hannah Ritchie. And Steve, over to you. Take it away.
Well, thank you, Vernon. And before we dive in, I just wanted to remind you that we couldn't do this without your support. So if you can, please consider sending us a donation by going to LOE.org and clicking on Donate at the top of the page. Even a little bit helps. Also, InsideClimate.org wouldn't mind getting a tickle from your bank account as well. We are very happy to have 10 copies of Clearing the Air generously donated by the publisher, MIT Press, to give away to the first 10 people who donate $50 or more. And that's a bargain because the book costs on the scale of, let me just double check. I'm sure that it's at least $35. And so you can donate $50, get a book, and help us. Please also note that you can send any questions you have in the chat, and we will try our best to incorporate some of those questions into our conversation. So without further ado, Dr. Hannah Ritchie, welcome to Living on Earth.
No, thanks so much. It's great to be here.
It's wonderful to have you. So, after I read your book, I said a good title for this might be Truth, or maybe a little longer title, Clearing the Air with Truth for People. The concerned, the skeptical or active, and feeling like progress just isn't being made. But this book is full of so much hope, and data is your answer. And so how do you make sure your data is true?
Yeah, it's a very good question. I mean, I think part of the challenge and part of the reason I wrote the book is because people see so much conflicting data and information, right? Like, I think often when people are looking for information on a particular climate solution or looking at a particular climate impact, I think part of the challenge that they have is that they see a number in a news article or a headline, And because there's a number there or data there, we put so much emphasis on that, right? We put so much trust in that number. And then because that number's there, that means that that number becomes incredibly credible. And carries a lot of weight. And I actually think that's part of the challenge for people now, is that they just see a number and it's extremely, extremely hard to put that number into context, which is what I try to do in the book. I mean, the data I use comes from a range of sources. There are, like, on climate and energy in particular, are very kind of large international databases which basically collect emissions data and energy data from countries across the world and publish these very large data sets. So part of it comes from there. A lot of it comes from academic research, right? Like, part of my work, and my work on climate, but also our work on our own data, is trying to bridge this gap between the research that exists, the valuable research that's been done, and then putting that in an understandable way for policymakers, journalists, people that want to make a difference. Often there's this gap where people have really pressing questions, and the answers are there, right? Scientists know it or researchers know it, but they haven't communicated it properly. It's in a kind of academic journal that is full of jargon and no one can understand. So it's this mix of data sources that I rely on.
How do you handle the complexity of data? I mean, us humans, as you point out in your book, have trouble with big numbers. 1,000 is big, maybe 10,000 we can comprehend. But then as it gets bigger and bigger and bigger, it's just really hard to understand and kind of how do we compare things and put things in context. And of course, also the age of the data, because you're very polite to the Intergovernmental Panel on Climate Change, but a lot of their stuff is out of date these days, from what we know now. So how do you address those issues, the scale and making sure that everything is contemporary?
Yeah, I mean, the Intergovernmental Panel on Climate Change, I think, partly highlights the issue that research often tends to be quite slow, right? So the IPCC have these really large and really fantastic reports, but they're often very, very spaced out in terms of time. And a lot can change over that period of time from one report to the next. And I think that's especially true when you're thinking about the technologies and solutions that we need here, where often you will find numbers or impacts being reported that are 5 years out of date. And 5 years might not seem very long, but the technology, the costs, the impacts have evolved so quickly that couple of years makes a huge difference to what the landscape looks like. So getting really up-to-date data is difficult, but I think really, really essential. And as you say, I think the context is really, really crucial. That's a big part of my job when I also come across a number, and I don't have some superpower here. I go through the same questions that I think I advise in the book that other people do, where I come to a number, I also don't have the appropriate context to understand, does this matter, is this big, is it small? But trying to find a way to put that into context, I think, is really, really crucial. And it's really, really crucial, one, to know, is this a big deal? It's also really, really crucial to understand if a particular solution is greenwashing, for example, right? So you'll often hear reports of this fantastic solution that saved, 1,000 tons of carbon dioxide. And of course, 1,000 tons of carbon dioxide sounds huge, right? Wow, we've found this massive new solution. And the reality is that we emit 36 billion tons of CO2 every year. So it's being able to understand that context that's really crucial. So my general advice is always, when you see a number, ask, is that a big number? Is that a small number? And compared to what?
Compared to what? Yes. And well, let's cut to the chase here. People are somewhat skeptical about dealing with the climate. I mean, we've been talking about it for so long, and it doesn't feel like a lot of progress is being made. So the people who are concerned, they're getting a little tired and wondering. The skeptics say, see, they don't really know. So I want you to dive into the very first question of your book for a moment, which, sets things up. It's one of the, quote, big questions you have in your volume, as you call it, and it is simply 4 words. Is it too late?
Yeah, and I think it's a question I hear a lot, where I think people do feel very despondent. They feel like we've been on this journey for a long time. We've kind of delayed, and oh no, now it's too late and there's nothing we can do about it. And I think the reality is there is just stuff that we can do, and it's actually never too late. I think what I caveat that around is that there are particular temperature targets for which the reality is that it's too late, right? So I think lots of people pin this around keeping temperatures below 1.5 degrees. Now, I'm optimistic, but I'm not that optimistic that I think that we can do that. I think that the reality is that is too late for us now. Like, we just will not be able to achieve the 1.5 degree target. But what's really, really crucial is that does not mean that it's too late for us to take action and limit temperatures even more, right? The way that these climate impacts work is the higher the temperature, they increase the danger and the hazard, right? So even if when we go past 1.5 degrees, fighting for 1.6 or 1.7 or 1.8, those incremental changes in temperature do limit damages, and it's worth us investing in those solutions to prevent those damages as much as we can. So no, it's never too late. There's no point at which there's just no point in us trying to take action and limit temperatures as much as we can.
So how do we get to the feeling of, yes, we are really addressing the climate emergency? I mean, how do we get to that point if it's not too late?
I think the reality is that it's already happening. I think people have the sense that no one's doing anything, governments aren't taking action, no one cares. And I think in some sense that's quite a dangerous position to be in. I think that's too dangerous, that mentality is dangerous for two reasons. As individuals, I think that gives us a sense of, well, what's the point in me trying if no one else is trying? But it also matters for what we ask of governments and companies and financiers, right? If the mentality is no one's doing anything, then we don't have any expectations that others do stuff, right? But if there is this general message, stuff is happening, that country over there is doing this company over there is doing this, that puts pressure on other governments, other companies to take action as well. And I think that boils down to the individual as well. When you can see that other people around you are stepping up and taking action, I think it motivates you and in some sense puts pressure on you to also step up too. So I think this mentality that nothing is happening and no one cares, I think is quite a damaging one. I mean, I think there are lots of signs of progress across the world. I think one of the most optimistic changes for me in the past decade has just been the plummeting costs of renewable energy technologies, right? So when we were looking at this 10 years ago, it was very, very hard for me to see how we would make progress, because the reality is that solar and wind and batteries and electric vehicles were all much, much more expensive than the fossil fuel alternatives. So to me, it just wasn't viable that people would take those extra costs, or could I even afford to take those extra costs for the low carbon option? Now that's flipped and that's the opposite, right? So many of these low carbon technologies are also economically viable or economically competitive. Plus you have the climate benefit as well. And you're seeing that in terms of deployment rates. Like, you look across the world, most of the new electricity technologies being built today are not fossil fuels, they are renewables. You've seen increasing shares of sales of electric vehicles, right? So take the example of China. In China, now more than half of new cars in China sold are electric. Many other countries are up at 98%. So Norway is up at 98%. So you can look across the world and there are lots of pockets where you can see that progress is happening. And importantly, progress is accelerating. This stuff is getting faster and faster every year.
So one of the intriguing pieces of data in your book is about the attitudes of folks here in the United States and the world. You say that, hey, a majority of us are concerned about climate disruption, that it's a problem, but of course we give it less attention than the economy and health and so forth. What does your data say about those attitudes and in other places? And by the way, your data also says that in this country, the United States, there are more of the so-called red states, conservative states, that are using renewable energy to generate electricity than the more so-called liberal or blue states. In other words, the majority of us in the United States seem to be concerned about the climate. Even the most conservative places are going to renewable energy. And yet there's this sort of dark cloud of gloom over, the climate really can't be addressed. What do you think is going on, and how can people get out of that funk?
Yeah, I think there are two attitudes there. The first is this kind of blanket, no one cares, right? Which the data very strongly suggests in every country in the world that's just not true. In every country in the world that's been surveyed, and that's a large number, the majority of people, believe in climate change, care about climate change, are concerned, and want to see governments and other policymakers make effort to take climate action. So the notion that just no one cares is just not true. The majority of people do care. And the second thing that people always bring up is this polarization issue, where often it's framed as people on the left care about climate, but people on the right do not care about climate, and we struggle to make progress because we can't bridge this gap. For most countries in the world, even that polarization gap is really, really small, right? The US is actually a bit of an outlier here. So the US is much more polarized than other countries. So the gap in other countries is very small. But even in the US, I think the gap is exaggerated, right? So the majority of people on the left care about climate, but also more than half of people on the right also care about climate, right? So this notion that it's only people on the left that care about climate is just not true. But that breaks down even further when you actually just stop talking about climate and you just talk about clean energy. Actually, the share of people on the right that support clean energy goes up even more. And you can see that in attitudes, but you can also see that in what's actually happening on the ground. Where if you look at where renewable energy is being built most quickly across the US, is in incredibly red states, right? It's not blue states, it's red states, right?
Yeah.
So Texas is a very clear example. So Texas has been building huge amounts of solar, huge amounts of wind, has now taken over California in terms of how much of this it's building. It's really investing in battery storage, these technologies that people might frame as being lefty, right? Some of the reddest states in the US are building them out very quickly. Now, part of the driver there might be climate, but part of the driver is just other stuff like local air pollution or economic gains or employment. And I think it's really, really important for us, if we're to try to bring as many people along with us as possible, is yes, focus on the climate aspect of this. This is really important, but focus on the other stuff that people care about as well. These co-benefits of clean energy, which is not just about climate.
Interestingly enough, Inside Climate's reporter, Dan Garino, was out in Iowa not so long ago. And Iowa, as you point out in your book, is a red state that has the largest proportion of renewable energy. I think it's like 65 or 63%. And yet, when people move to try to install more wind power there's sort of a thread of disinformation that sometimes comes out into the discussion there with wind power. And so what about disinformation? Where does your data say that it comes from? And what, according to the data, can really counteract it, do you think?
So I think it's an interesting question, because I think there is what we might frame as disinformation, which is almost kind of deliberately trying to give someone facts or information that's false, right? Knowingly, basically telling lies, right? So that's one aspect to this. And I think there's quite a bit of this. I think that there's quite a lot of deliberate disinformation, often because there are incentives to not shift towards clean energy, right? If you are in the business of fossil fuels, you don't really want this transition to happen. So there's some incentive to deliberately, seed doubt. But then what I actually think is more powerful and more persuasive is misinformation, which is not necessarily deliberately telling lies, but it's kind of white lies. You kind of plant a kind of half truth and don't give people the complete picture by which they would be able to understand whether this is correct or incorrect. I bet it kind of comes back to this context thing, right? Where actually a lot of the most dangerous misinformation is like planting a little seed of doubt or a little half-truth, not giving all of the numbers, just like giving one number that sounds kind of big or kind of small, depending on the context. And I actually think that's more damaging for people than the very, very deliberate disinformation. Often it's easier to spot the disinformation. I think a lot of people are clued into that. It's very, very hard to spot misinformation, especially if you're not an expert in that given area.
Is there an example you'd like to give us on the misinformation that you think has that effect?
I mean, I think coming back to wind energy, right? So, like Donald Trump's favorite line when he talks about wind energy is that wind turbines kill millions of birds, right? And that's one reason why we shouldn't deploy wind power. Now, it's actually correct that wind turbines across the US kill a couple of million birds every year, right? What's missing there is the context of whether that's a little or a lot compared to other hazards to birds, right? So in the book I have this chart that shows, basically hazards to birds in the US. And actually the biggest one is cats, right? So cats in the US kill billions of birds every year. Buildings, fertilizers, roads, these are all much, much higher than wind turbines in terms of the risks and the threats to birds. So I think that's just like one very clear example where like it's actually the statement itself is true, but without the context, it's really hard to evaluate whether that should be a blocker on us going forward with wind power or not.
There's another area that perhaps is related to misinformation or disinformation that you have in your book, and that's about nuclear power. And there's this public perception that nuclear power is really dangerous in this country, tricky. People make bombs with it. After all, there was Chernobyl. And it's way too expensive. But your book suggests that, nuclear power is on a par literally with wind and solar as a carbon-free, safe, and relatively reasonable way to get energy. Can you talk about that, please?
Yeah, I think this is a very, very common misconception about nuclear power. It's very dangerous. That's actually been the kind of strongest opposition. It's been strong in the US. It's very strong across Europe. Many countries have basically shut down their nuclear power plants because of public concerns about safety. And I think there are a couple of reasons for this. I think the main one is that when people think about the hazards to nuclear power, it comes back to a few very, very specific headline-worthy events, right? So there's 3 Mile Island, there was Chernobyl, there was Fukushima. So there's really memorable, single, dangerous events that happened, and that's what comes to mind for people. But when you look at how many people died across those events, I mean, Fukushima, right? You had a huge tsunami in Japan, hit a nuclear power plant, and no one died, right? It's actually pretty incredible that a tsunami hit a nuclear power plant and no one died from that particular disaster. Chernobyl, the death estimates vary from some hundreds to a couple of thousand, which is of course tragic. But when you add up the number of people that have died from nuclear power over 50 years or more, it's in the thousands, a couple of thousand at most. Now, again, it comes back to context, right? So if you to compare that to how many die from burning fossil fuels, right, one of the alternatives, we have millions of people dying prematurely from fossil fuels every single year, right? So you have millions every year compared to thousands over decades. So when you break it down by, how many deaths occur per unit of electricity produced, burning coal or gas or oil is order of magnitude more dangerous than nuclear power. So the notion that you shouldn't move to nuclear power because it's more dangerous than fossil fuels is just incorrect. But I think it's very, very persuasive and plays a huge role in public perception.
Indeed, and concerns about the waste, for example, which your book points out are greatly exaggerated, if I read that correctly.
Yeah, I think if you were to ask nuclear scientists and engineers, are we capable of handling radioactive waste? The answer is yes. I think the one challenge there, and what I emphasize in the book, is that from a kind of theoretical perspective, storing this very radioactive waste over very long timescales is technically feasible. The challenge is that no country has done it yet. And I think that countries do need to invest in trying to do this in a long-term way and in a safe way in order for that trust to be built, right? So you can say, scientists can say as much as they want that, this is safe and we will be able to do this, but until a country actually steps forward and does this kind of long-term geological storage, I think people will always doubt that this is the case. Some countries are actually moving forward with this. So Finland kind of is a leader in this and is currently building a repository. So, but yes, I think nuclear waste can be managed, but I think countries need to step up and show that it can be done.
So I'd like you to take a few minutes to talk about your process in creating this book, Clearing the Air, because, and I mean this in a positive sense, you have a strong formula here to bring people into your questions. You divide up your book into, well, actually, you should describe how you divided it up and the ways that you then bring people along to understand the data in each of these questions.
Yeah, I mean, all of the questions in the book were motivated by questions I get all the time, right? So questions in interviews or over email or at book events. They're genuine questions that people ask, and a lot of people ask. So the kind of method there is like, how do I write trusted answers that people can engage with and feel like they walk away with a good understanding of what the answer is there. Each question is relatively short, right? So part of the challenge was trying to answer, actually sometimes quite a big question in a couple of pages, but it's kind of broken into sections based on the kind of topics. So, renewable energy technologies, fossil fuels, electric vehicles, and minerals and mining. And I go through these sections and answer these questions one by one. Part of the challenge always is that I have more to say than I can say in a very short amount of pages. So each section basically each question has, basically the kind of core answer that I think people need. And then most have a kind of things to bear in mind at the end, which is basically me trying to cover all of the complaints that I know I'll get. I'll be like, oh, you didn't mention this thing, or you didn't mention this. So in the things to bear in mind, people can skip them. But, for the nerds that will really want to dig into like how this methodology works or what some of the caveats are, they can dig a little deeper.
Yes, but then you go on to say what we need to do to respond to the things that you point out. So talk to me, how did you develop the various prescriptions that you have in response to, once you answer the question? For example, well, we don't have to go back into nuclear, but once you answer the question, you then suggest what is to be done. So actually, let's go back to wind. What is the answer? What needs to be done? Yes, it doesn't sound great to have a couple million birds dying every year. And things like, big birds like eagles, in fact, can have trouble. And birds aren't, well, bats aren't birds, but they also have trouble with wind turbines. And then you have what we can do about it. That part is fascinating. You want to share how you suggest that we deal with it?
Yeah, I think this part is really crucial. I mean, I'm very positive about the solutions that we have to work with and are continue to develop. But the honest answer is that they're not perfect, right? It's not that, any of the solutions don't have any mining impacts or any land use impacts or any impact on wildlife whatsoever. So for each of these questions and these solutions, there are things that we can do and need to do in order to make things better. So to take the bird example, I don't think that the fact that wind turbines kill some birds means that we should stop wind power entirely, right? I think we need to continue and go ahead with the transition. But along the way, there are things that we can do to reduce that toll significantly, right? And there are a range of projects and implementations that actually really make a difference. So, for example, there's been experiments where if you paint the blades of the wind turbine black, or put kind of rings of black on the wind turbines, birds and bats can see them much better and are able to avoid them. There have been experiments where if you, for particular birds, and particularly birds of prey are very much at risk, if you basically switch off the turbines at very, very low speeds where you're not generating much power whatsoever, it dramatically reduces the death toll from birds. So I think the numbers are around, you more than half the number of birds that are killed. And the amount of energy you lose by turning the wind turbines off at very low speeds is like something like 0.1%. right? So you're not losing really any money, you're not losing any kind of energy generation, but you're more than halving the number of birds that are killed. For bats, if you play often ultrasound sounds, it allows them to detect them. So there are a range of things across these different solutions that means that we can make things better and actually reduce the impact even more. And I think it's important that we be able to do both of those things at the same time. Like, we know that we need to go ahead with the energy transition and get a move on. So that shouldn't stop us or halt us from doing that. But there are certainly things that we can do along the way in order to do that in the most responsible way that we can.
Here in the United States, the present government's policy has really been to push back hard against EVs, electric vehicles. And unlike other parts of the world, and of course, the basic numbers are quite available. The Chinese are building them like crazy. Places like Norway, or like most new cars are being sold are electric and such. But there's huge pushback in this country about electric vehicles. And so just talk to us about, and I don't want to spend the rest of the time talking about the various myths, but just talk to us about a few of the myths that are promulgated and the actual data answers to them.
Yeah, so I think there are a lot of kind of physical characteristics of electric vehicles that, get a lot of criticism. Like one of the key ones that people have is what we'd frame as range anxiety, where I think there's the sense that the batteries run out extremely quickly, and there's no way that you could use this in your daily life. You just constantly run out of battery and break down on the highway, right? And this is just not a reality. Most very good electric vehicles, get several hundred miles of range, and some are pushing 400 or 450 miles of range. So I think if you have to speak to anyone that has an electric vehicle, you get the sense that this works for people, right? They manage to charge, they don't break down on the highway. There is more than enough range in many of the current models that are available. There are myths around the physical characteristics that they just don't work in the cold, right? So you'll often hear this: the batteries don't work in the cold. And the reality there, again, it's like a little bit of the seed of truth, but missing the context. So the range for an electric vehicle does go down when it's very cold, but it's usually about 10%, 15% once you get into negative Celsius degrees, right? So it's not that the battery stops working and you can't drive anymore, right? You just lose around 10% of range. And that's important for consumers to know. But again, for most people, that will just not be a barrier in them getting an EV and be able to drive on a daily basis. And then I think the really core one that I think for a lot of people matters is cost, right? Where historically, electric vehicles were very expensive. They were very expensive because they were niche, they were new technologies, they hadn't developed. And you've seen this really, really rapid drop in costs, largely because of the dropping costs of batteries. But, China is now making extremely good electric vehicles and selling them at, $10,000, right? And they wouldn't cost that in the US, and they also cost more in Europe. But they're often getting cost competitive upfront with a gasoline car, and they're actually much, much cheaper to run. So when you look at the cost of running an electric vehicle versus a gasoline car, they tend to be much, much cheaper. So there are a range, I could go on, but there are a range of, I think, seeds of misinformation out there that I think discourage people from investing in an electric vehicle. So I do think that's changing. I think it's changing more slowly in the United States, but I think across Europe, across China, across other countries in Asia, South America, I think this is actually evolving very rapidly.
Yeah, an eye-opener in your book about less range in the wintertime. You point out that gasoline, also is less efficient in the wintertime, and mileage is worse. And Vernon is back with us now and has a question for you. So why don't you proceed, Vernon?
Yeah. Hannah, I'm wondering whether you're at all concerned that your sort of optimistic projections that the worst case 4 to 5 degrees warming by the end of the century are not going to happen. If you're concerned that those projections could be affected if, say, the Trump administration, the Trump movement becomes a permanent movement, not only here, but around the world. We've already seen the rise of authoritarianism in Hungary and Italy and other countries. Is that something that concerns you, that Trump is not an anomaly, but in fact a trend, that this sort of pro-fossil fuel trend that could really tip the scales back away from renewable energy for the rest of the century?
No, is my answer. I think obviously Trump is not good for climate action, specifically in the US. Like, I think the reality is that the US will be set back several years in terms of its energy transition. Like, there's no doubt about that. But I struggle to see how you can stop this trend now, right? I think you can slow it. I think you can certainly slow it. But I think it's very, very unlikely that this trend stops now. And I think the core reason for that is economics, right? I think, again, as I said earlier, I think 10 years ago, it would have been much, much easier to basically really block forward progress on this. But the reality is that for many of these technologies, they're just undercutting the costs of fossil fuels. And if you look outside the US, across Asia, across South America, across Africa, most people just want cheap energy, right? And if someone is offering them cheap renewable energy technologies, they will take it over the fossil fuel alternatives. So I think and I get asked this a lot, are you still optimistic despite Trump, right? And again, I'm not optimistic about the US specifically in this situation. I think action will be delayed. But when you look in other parts of the world, they are just charging ahead and really not paying much attention. If anything, as actually more of a driver to lean into the energy transition, almost as a kind of competition to this kind of what you might frame as a kind of petro state, right? So I've often hear it framed as kind of petro state as the US and an electro state as as China. And if you look outside the US, you just don't see this slowdown. If anything, you see an acceleration. I mean, for more than a year now, China's emissions have been plateauing or falling. Last year, India's power sector emissions fell for the first time in terms of a kind of structural decline, because renewable energy technologies are just so cheap and they just will be built.
Yeah, I thought your discussion of China was fascinating. Your point that China may be close to peak emissions and that while they're still building coal plants, they don't use them all the time, which is something I didn't know. And of course, their dominance in wind, solar, batteries is unparalleled. So I guess they're the counter argument to the US.
Yeah, I mean, I think a lot of people, like an argument I come up against a lot is, why should we do anything because China, right? Mm-hmm. And the reality is that China is just a huge global emitter. Like, it's the world's largest emitter. If China doesn't act on climate change, like we won't be able to tackle this. But the reality there is that China is actually moving very fast on this. It is deploying huge amounts of clean energy domestically. So now every year, China is adding a UK-sized grid of solar and wind. Every single year, it's building as much as the UK has in total. It's going extremely fast on deploying electric vehicles, and it's also exporting huge amounts of solar panels, batteries, etc. to the rest of the world. So it is really, and again, part of the motivation here is climate, right? Like, China just also will face huge challenges when it comes to climate change. But there's also been other drivers of this. There's been a huge push in China against air pollution, which has been extremely, extremely successful in the last decade. And it just sees this transition to clean energy as its core industrial strategy, right? Like, this isn't just came about in a year or two. This has actually been decades in the making and is now coming into fruition.
What does your data tell you about the linking up clean energy and health issues, and how that might be driving the trend towards change? I mean, you briefly kind of alluded to that about China. They had really bad air as they were getting ready for the Olympics, and they shut down a bunch of plants, and I'm not sure they ever really started up all those coal plants again near Beijing. And as you pointed out earlier, in comparison to nuclear, which maybe a few thousand people have died in the last 50 years, millions every year. I mean, the Harvard School for Public Health says 7, 8 million around the world, a third of a million here in this country. What does your data tell you about how bringing those figures together, bringing those stats together of the advancement of clean energy and advancing public health can come up with an even stronger story for making this change?
Yeah, I think when you break down the numbers, the reality is that currently more people are dying from air pollution than are dying from climate change, right? Like, as you said, we're talking about millions of people every year dying prematurely because of exposure to air pollution, a huge part of which comes from burning fossil fuels. So the health burden of this is extremely large on a global scale. And I think for many countries, this a big driver has for deployment of clean power has been this kind of local air pollution story. Again, part of it because there's this sense of control, right? The reality of climate is that no country on its own is in control of the climate. Therefore, you're kind of in this kind of reality where you have to rely on others taking action. And do you take action or do they take action? Which maybe limits collaboration a bit. But when it comes to domestic, local air pollution, a country or a city is in control of its local levels of air pollution, which gives people a sense and a drive on a different scale. So I think that has been just a very, very big driver. And you can actually see it when you look at public survey data of what people care about, right? So in the UK, this kind of polling company, YouGov, have been running this poll for more than a decade where they ask a large number of the public frequently, what are the top issues facing the country? Now, climate and environment always ranks pretty highly, right? It's usually like 4th or maybe 5th, right? So not at the top, but it ranks pretty well. What it never beats is economy or cost of living. That's nearly always top, is economy and cost of living. Again, why we need to focus on, is this affordable? The costs of this for people, because that's also what they care about. And health is nearly always second, right? So when it comes to people's drivers to or kind of motivation to look at clean energy technologies and support them, climate's there, but actually the health angle tends to be even stronger, right? And the good news is these go together, right? You don't trade off one with the other. But I think it is for many people and many governments a big motivating factor.
Vernon, when we were getting together preparing for this, you had some concerns about EVs. Maybe you want to raise these now.
Yeah, I was just saying that I found Hannah's section on EVs and the questions just very sort of illuminating and useful. For example, I think one of the questions dealt with, is it true that EVs catch on fire all the time? And Hannah, the answer to that is...
much less than gasoline cars.
Exactly. Another one was just simply, is an EV cheaper to drive than a gasoline car? And the answer is, again, very helpfully,
yes.
Yes, by far. I mean, by a lot. And so I that's why I think the book is so useful. It just sort of gets rid of all the noise, gets down to somebody's life level, somebody who's thinking about buying an EV, and just answers the question, it's cheaper to drive an EV. So again, very useful book. Hannah, I was also really interested in your apportionment of responsibility between the societal level action and the individual action. And I was kind of interested that you really didn't let, individuals off the hook. And while no single person can really do much to solve climate change, you said there's actually a number of responsibilities that individuals have to be mindful of.
Yeah, I mean, I think when it comes to this kind of argument of who's responsible and who should take action, like often you find people at one or two extremes, right? So some of the kind of narrative is that, as individuals, if we all just do our bit, then we'll solve this. And I don't think that's true. I don't think that's the reality. But you have the other end of the spectrum, which is that this is being caused by and needs to be fixed by big companies and governments. and they need to take action. This is purely a systemic problem, and individuals just don't matter. And I also think that's incorrect, right? I think the reality is this is an ecosystem where, of course, governments need to take action, companies need to make the right decisions, the solutions that we need to be available, they need to be affordable, they need to be accessible for individuals. But I think the reality is, as individuals, we cannot expect that to happen if we're not motivated to change ourselves, right? So the example I use in the book is transport, where you can and I would make the argument that it's on governments to put the right policies and incentives in place to motivate alternatives to gasoline cars, whether that's public transport, whether that's electric vehicles. As companies, like, we need electric vehicles or trains or whatever the public transport is to be there, be available, be affordable, and be competitive. But they're not going to do that, and there'd be no point in them doing that if we all just sit and say, no, I really love my gasoline car, I'm never going to switch away from it. Like, that just obviously just doesn't work, right? So you need the systemic change there to be there. But as individuals, we can't just sit on our hands and expect to do nothing and for things to change. We also need to be willing to accept those and take on those solutions and ask for the right things.
Okay, so along this line, and towards the back of your book, you bring up the other elephant in the room, kind of around climate, and that is food, and in particular, meat. And so there's a lot of, people feel quite attached to their culinary habits. In this country, of course, the government really supports a lot of meat. I mean, we let people graze cattle for virtually nothing in the West, and we have a whole system of distribution that really keeps the price of meat relatively low, and we subsidize the grain that is grown for them. And yet, of course, it is an individual choice what we put on our plate and what goes in our mouths. I'm not going to ask if you're a vegetarian. I'm not going to ask... I'm not going to ask Vernon if he's a vegetarian.
I am.
I'm going to, and I have, from time to time, I've been a vegetarian, I guess is the answer. And so how can we get that out of the having people feel a little challenged by this and in this country, well, I just know when I travel, when I go to a restaurant, for example, in this country, man, they kind of look at you if you look at the menu and you say, there's not much here for a vegetarian, for this group of people that I'm with. And you kind of get like well, come on, are you a real American or something? Come on, eat some cow. How do we get over that hump? You write about this.
Yeah, I think with quite a lot of difficulty. I think, well, first of all, I think food is really, really important in this story. Like, I think we always focus on energy and fossil fuels, and of course that's a huge part of this. But our food system is between a quarter to a third of greenhouse gas emissions, right? So we also need to tackle this along with focusing on energy. And as you say, in terms of the ranked choices or solutions that we have in this space, reducing meat and dairy intake is basically the biggest lever that we have in order to reduce some of those emissions. I think food and our progress there on decarbonising is much slower than it is on energy. And I think that's because people are much, much more attached to the food that they eat than where their energy comes from, right? I think for a lot of people, they plug their computer in or they switch their lights on, and maybe they know a little bit about where the energy is coming from. They don't really care or know that much, right? They just want reliable, affordable power, right? Which in some sense makes that transition easier. When it comes to food, you're making your own personal decisions 3 or 4 times a day, right? And for people, that's just an extremely kind of individual personal choice. And people quite rightly get angry if they feel like someone's trying to dictate or change their choice in some way, which makes this extremely challenging. I think our best hopes here is the reality. People just like meat, right? They like the texture of meat. They like the taste of meat. It has this kind of cultural significance to people. for me, this, strongest solution that we have is basically to try to provide meat-like products without the animal, right? For people, that will just be the easiest switch, right? So you go into a restaurant, you're having a burger. The burger's not from beef, it's from a kind of low carbon alternative that's not from an animal, but the texture is the same, the taste is the same, the smell is the same. For most people, that's the easiest swap that we can make. And I think there the technologies are getting better. There's been actually kind of huge progress in the taste profile and the texture profile of these products, especially over the last 5 years. The hard part is getting people to try it. And actually the data there is quite promising that when people do try it, they'll really like it. Often in blind taste tests, people prefer the meat-free alternative over the meat burger. The trick there is that when you unblind it, they go for the meat burger again. So this is the tricky part. This is the tricky psychological part. But the products in this space are getting much, much better. The hurdle there is this kind of psychological, I think, barrier that people have to these alternatives. And psychology is unfortunately my weakest point. I find it really hard to know exactly how to change that psychology and those behaviours. But to me, that's the most credible path by which we get there.
So we're starting to get a little tight on time here, but there's a question from somebody who's watching us that I'd like to inject into the discussion. It takes us back to nuclear power. And this person says that this person took a course in nuclear energy taught by a nuclear engineer who promoted it, but still very concerned about the storage of the waste. So drill down a little bit more on safe storage for nuclear power waste.
Yeah, so when it comes to nuclear waste, there are different levels, and we call it kind of levels of radioactivity. So you have very, very low levels of radioactive waste, and those can basically be stored quite safely at the surface. So you'll often see them in these big casks, these kind of, multi-layered, cement-layered casks, and they're relatively safe at the surface. The most challenging, you basically go down there from kind of what we call intermediate waste, which is a bit more radioactive. The most concerning stuff is the very high level radioactive waste, where the radioactivity levels are very high and basically will be for thousands of years. There's different estimates on how long that time period is. It's at least 1,000, sometimes it goes up to 100,000. So you basically need to be able to store that safely, not just for our generation or our next generation, but many, 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 many generations, right? So the kind of proposed and most likely method of storage there will be deep geological storage. So you basically take those multi-layered casks and store them deep, deep underground. You obviously need to find a kind of geologically safe, so you're not going to put it in an earthquake zone, right? You're not going to put it where there are kind of groundwater sources. So you basically need to find a really, really safe deep geological site and store it there. Now, most kind of scientists would say that that's feasible, technically feasible, and this stuff is starting to be built. So this kind of Finland, the Sankala repository is exactly trying to do that. But I think that's coming back to what I said earlier, I think that's the key point, is that we actually need to kind of just keep saying that, yeah, it'll be fine if we can do this. I think countries need to step up and actually make that a reality for people to start trusting it.
I thought you might answer that the way that we just take a small percentage of the energy out of the uranium that we use for nuclear power, that there's some places that just keep reprocessing it and actually doesn't become waste. It simply becomes a source of energy.
Yeah, you can basically, you can reprocess a lot of the waste and basically put it back in as a fuel again. France does this a lot. The US does this very little. So there's lots of scope there to reduce the amount of waste that you would produce, and also just reduce the amount of fuel you need for nuclear power in the first place. You will still have waste at the end of the chain, but you can kind of dramatically reduce the amount of resources and waste that you need.
We also have a question from someone who says, your views on the potential for carbon capture technology.
Oh, not that optimistic. I mean, I think it's interesting to see how discussions there have even evolved over the course of 10 years. And the reason for that is because, to me, the reason that you would do carbon capture and storage is if you basically have no alternatives left by which to get rid of the carbon and stop it being emitted into the atmosphere. And the reason I say that is because as soon as you add a carbon capture and storage repository and process, you add costs, right? So if you have a natural gas plant, as soon as you add carbon capture and storage on the end, you make it more expensive. Same with a coal plant, same with any technology. And I don't want cost of energy or these technologies to go up, right? I want us to find cheaper alternatives. So if you can find cheaper alternatives, that is just much, much more favourable than going for carbon capture and storage, which makes stuff more expensive. And the landscape has changed a lot in just 10 years because we have found more affordable alternatives. So I remember in the UK, now the UK has now coal-free. In the last few years, we shut down our last coal station, which is actually quite an amazing achievement. We were kind of at the beginning of the Industrial Revolution, and now coal is gone. I think that's quite significant. And a lot of that has been replaced with the rollout of solar and wind. But it wasn't that long ago that we were talking about, well, we'll do carbon and capture and storage with coal plants. And that was actually a very, very, kind of laudable or realistic solution to our coal problem. So we would never get rid of coal. We would just add a carbon capture and storage plant on the end of it. Now that sounds a bit ridiculous. We just would never do that because the alternatives are there. But when the alternatives were expensive, that seemed like a very, very viable solution. And I think there are a range of different carbon capture and propositions for which the window by which we would need it is closing and closing and closing because we're gradually finding better alternatives. I think there are a couple of areas where carbon capture and storage might be needed, right? Like so stuff like cement. Like one of the proposed solutions for producing low carbon cement is that you would collect the carbon and store it underground. But even there looks like there were probably more promising ways to do that by changing the entire process. So you don't need to get rid of the CO2 at the end of the chain anyway. And I actually think those alternatives, again, will probably win. So I think there's probably a small role for carbon capture and storage to play, but I think the amount that we'll have to rely on it is shrinking and shrinking and shrinking because we have increasingly better alternatives.
I think you say in your book, in fact, that even under the most optimistic scenarios, carbon capture could capture 1% of emissions.
Yeah. We're talking about, percentage points of emissions, yeah.
Yes, exactly. So your book very carefully doesn't go too deep into, as you say, psychology or sociology or even politics. And yet so many of the things that we're challenged by involve, on certain levels, private businesses and public policy. And in, for example, you talk about utilities. I mean, getting the grid, right? Getting the grid going. In this country, and in other places you mentioned, it takes thousands of permits to put in a grid line to go through private areas. Whereas a century ago, pretty much electricity was a public utility and the lines were public, like the way the roads are pretty much public. But now our utility system, our grid system is much more like a toll road everywhere. How do you deal, what do the numbers tell you about ways that public sharing, government things doing these will be faster and more efficient and cheaper for us in the long run than having private companies individually compete and, of course, try to make some money on it. In the face of, as you say, it ain't too late, but we got to act quickly.
Yeah, I think it's a combination. Like, I think that some areas, kind of public government action makes more of a difference. I think in others, you're often relying on private companies to step up and do that. And I think it partly depends on the specific context. I mean, I think the grid is a very good example where I think people's perception of why the rollout of renewable energy is what they might deem to be so slow is because people don't want renewable energy projects, or there's not enough waiting to be built. There's just loads of projects that are waiting to be built, right? What we call the kind of interconnection queue, where in the US, something like basically the size of the US grid is sitting waiting in a queue of kind of proposed projects, and the limiting factor often is basically being able to get a permit to get a grid connection. And the US is not alone in this. This is the same across Europe. It's the same across many, many countries, where the limiting factor is basically these number of forms and actually getting this permit approved, which is just a huge blocker, and we just don't have time to for this to proceed so slowly. There are things that governments can do in this case, and some changes to the system that can make a difference. Like the UK is one example where the way that our kind of grid connection queue worked is it was a kind of first come, first served basis, right? So we could both have a proposed renewable energy project. You could be really serious, you have the funding ready to go, you exactly know how to go. I just have a kind of idea where like, yeah, maybe I'll build this, don't really have any money, but I'll join the queue. If I'm first in the queue, I'm first served, which makes absolutely no sense, right? They should serve the projects for which are most viable, will make the biggest difference, are basically ready to go. So actually the UK is switching from this first come, first served to this kind of merit-based system. So kind of unlocking this kind of permitting block is difficult, but I think there are things that governments can do to try and make that more viable and cut those times.
So you must have had some fun doing this, huh?
Yeah, I mean, part of what was enjoyable about it, and I think is just really, really important, is that not for all of the questions, but for some of the questions, I was also just coming at them, no idea of what the answer would be, right? And just willing to accept what the answer was. So part of it was also just discovery of me, is like putting into context, how much mining does solar panels and batteries need, and how does that compare to the mining impact of fossil fuels? Like, again, before coming to this, I didn't know exactly what the answer would be, so it was a bit of a kind of discovery process as well, which was extremely fun.
Yeah, and what's the answer?
Oh, the answer is that, again, people are very concerned about the mining impacts of renewable energy technologies. And there are impacts that, again, coming back to this, what we need to do next, there are ways and things that we need to do this in a more responsible way. But, if you look at the amount of mining that will basically need to build a clean energy system, over decades will be hundreds of millions of tons of materials, which again sounds huge, hundreds of millions of tons. There's no way that we could possibly do that. But then put it into context, and we're taking out 15 billion tons of fossil fuels every single year, right? So the amount of mining we need to do for renewables over decades is less than we need to do for fossil fuels in one single year.
And you were surprised when you saw that.
Yeah, I think I might have guessed that fossil fuels was a bit more, but I wouldn't have guessed it was order of magnitude different.
So, now let me ask you a little deeper about the social part of this. How do we get our different approaches? The Chinese have this very top-down, we would say, authoritarian system, different from the sort of authoritarianism that Vernon was alluding to with Viktor Orban and the aspirations of President Trump. But we have that, and then we have a lot more open societies. We have more traditional societies around the world. How what does your data, and this is not an easy question, and maybe it's not even a fair question, so it's okay if you say, I don't know. But what does your data tell you about where we can find the really great intersections among all these various interests to move forward to address the climate emergency? Because, as you say, we don't have that much time.
Yeah, I mean, I think the answer is that there's never going to be some universal system that every country is going to follow in exactly the same way. That's just not going to happen. And I think it would be actually set us back to try to push for that, right? I think what I would try to warn against is trying to find this is the exact way to do it. Everyone just do this, right? There are just different models of change across the world, and I think that's fine. And they have pluses and minuses, but trying to force a particular system on every country generally just doesn't work well. Often when you've seen this at the kind of international climate negotiations, they often break down when it comes to countries feeling like they are being pressed or pushed or forced in a particular direction. They actually tend to work much better when it's this kind of bottom up, every country step forward, say what you can do, we'll try and increase that over time. That has generally managed to reach broader international agreement than this top down, everyone's going to do this, and this. I think you just start to get pushback there. I think what's quite exciting about this is that because the systems are so different and actually countries are doing well in different ways, you can start to see different models that other countries that are more like one or another can in some sense replicate or copy. Right. So if you look at electric vehicles, the two countries that have done very well are China and Norway. They're just very, very different approaches, like vastly different approaches. And there might be some country that's looking at China and saying, well, of course, we're not going to replicate that model. But they might look at Norway and say, well, that's a model that we can maybe roughly follow. So I actually think having that diverse set of models of success is really, really crucial, because other countries can start to see, well, we can't do what they've done, but that other country over there, we're more like them and we can probably do that as well.
Vernon, did you want to proceed for a moment here?
Yeah, well, to that point, Hannah, I found it very interesting in your book where you kind of answered the question about, well, my country emits only 1% of emissions. Why do we need to do anything? And I think you noted that if you added all those countries up, it would be 36% of emissions. And so it only works if everyone is in the game. And I thought that was a very powerful point you made.
And there are intersections, right? I mean, as you say, hey, the Chinese EV example and the Norway EV example, the intersection is in fact the EV.
The intersection is the EV, and often the intersection is the cost, right? So you can have very, very different politics across countries. You can have very, very different social dynamics across countries. What often makes a really crucial difference is just the difference in economics between one alternative versus another. And again, the structure of those systems, they took different approaches to, I guess, improving the economics. But the end result is that the EV was cost competitive with petrol or gasoline cars, and therefore people were willing to invest in them.
So it's fair to say that you are certainly not Pollyanna here in your representation of the facts and the data that are in your book, but you do remain a level of optimism. So what keeps that hope alive for you?
I think one, the data. Every day I see another data point that suggests we're moving in the right direction. And again, from very, very different parts of the world. Like some country in Africa has just, basically banned the sale of new petrol motorbikes, and now they're going electric. And you've got another country in South America making a change. I think this, following the data and seeing that stuff is happening, even though it might not make the headlines in the New York Times, right? But it's still happening. If you dig a bit under the surface, you can see that progress is there. And then just another reason I'm optimistic is I just come across so many fantastic, intelligent, driven people working on these problems and trying to make a difference. And again, often you just don't see this happening, right? It kind of goes on beneath the surface, but it doesn't mean it's not there. Whether it's, trying to improve technologies in batteries or solar power, whether it's trying to change government policies, whether it's trying to, change within a boardroom what a company is doing. There are lots and lots of fantastic people trying to make a difference. And that's what really keeps me going.
So what's your latest one or two of those?
Like changes?
Yeah, things that, oh my goodness, this is going on.
I mean, I think the one of the most recent ones has been the change in, I guess, not attitudes, but approach across sub-Saharan Africa, where there are actually now a number of countries in sub-Saharan Africa that have more progressive policies on electrification of transport than North America or some countries in Europe. I think there has been this narrative that the energy transition is only for rich countries and they'll do a bit, but the rest of the world are not going to do anything or can't do anything on this. And I think there are a number of stories emerging which is bucking that trend, right? There are countries that are basically, shifting, we might call it kind of leapfrogging, where they're actually taking the approach of, most people will just never have a gasoline motorbike or a gasoline car. They'll go from having nothing, like no car or transport, to having an electric one, right? It's this kind of leapfrogging approach. In a similar vein, some of the most, I guess, exciting data that I saw last year was this kind of really huge kind of hockey stick curve of imports of solar panels in many countries in sub-Saharan Africa, mostly from China. And again, I think this speaks to the fact that there's so many people in the world that just want affordable, reliable power. And that's really, really crucial. It's really crucial for development and their standard of living. And if there are renewable energy technologies that do that and are affordable, there's just a huge market there to take them. So I think it's those sorts of stories in other parts of the world that actually make me most excited.
Indeed. Those people in Pakistan who just get a panel and lay it on the ground, or in India, just so that they can get the electricity that way. I do think that we have to thank you, Dr. Ritchie, for taking time with us today and for writing this amazing book, which I got to confess, and I think Vernon would agree, we see a lot of books in this business and we talk to a lot of authors, but there are a number of people even on my crew at the show that said, this is amazing. I'm going to give this to my friends so that they can understand that there are answers to the questions that they all have, because they're all worried about this. Some are working hard on this and feeling like it's an uphill battle. And this says it's not easy, but it certainly is possible. And in fact, not only possible, but we're underway to make the transition we need to make. So many thanks to you for that. Vernon, you want to offer your thanks as well?
Yeah, absolutely. It's a terrific book. Like I say, I'm going to keep it on my desk, and I'm sure it's going to be dog-eared very, very quickly.
Oh, great. Yeah, thank you very much for your time.
And the dog ear is literal in his case. We both keep puppies in our office. So, and of course, I want to give lots of thanks to the UMass Boston School for the Environment and Inside Climate News for collaborating with us on this fantastic event. If you are curious about upcoming and previous live events, you just go to loe.org/events. And I'd like to remind you that we will be sending copies of Clearing the Air to the first 10 people who donate $50 or more to support events like this one. So if you enjoyed tonight's event, please consider donating to Living on Earth at loe.org. Or in the survey that'll pop up in a moment. InsideClimate.org won't refuse contributions either. Let me say thank you and good night.